Hi everyone, I'm Yifan Chen from Huawei Global Training Center. Today we are going to discuss how to choose open source internet architecture. In the business system compared to the hotel, waiters are responsible for customer reception. This is the presentation layer collecting customer requests. Chefs prepare the food, which is the service logical layer presenting dynamic user data as a portfolio. Purchasers procure the materials for the kitchen, which is the data access layer reading user data from various locations. A waiter can serve only one batch of customers at a time. As the number of dinners increases in peak hours, reception bottlenecks will occur, adding customer requests on the waiting list and deteriorating user experience. A traditional restaurant manager considers replacing the waiter with a more competent one by paying a higher cost. At the same time, the manager may hire another waiter in case that one of them asks for leave or resigns. Different between traditional restaurant manager, a restaurant manager with an internet mind may consider a distributed architecture. Because the number of dinners is large only at peak hours, the manager then hires some colleague students as part-time waiters, who worked in specific hours and are paid daily. This is distributed architecture coupled with elastic cloud computing. In other words, if one individual cannot handle a task, then call more workers to do it. For traditional architecture, if an individual cannot handle a task, someone who is more competent will be selected as a replacement. This reduces intercommunication costs, but involves a high risk of single point of failures and higher replacement costs. For example, if a server cannot handle a task, use a mid-range computer. If the mid-range computer cannot either, use a mainframe computer. To prevent this single point of failure, purchase another mainframe computer for the hot backup. For internet architecture, if an individual cannot handle a task, then call more people to help. This increases intercommunication costs, but no risk of single point of failure, and almost no replacement costs. In addition, the internet architecture provides numerous caches to improve overall performance. In brief, if a server cannot handle a task, use more servers and specify a cache for each service. In the initial environment, a server can run application and database software and store service files. When the number of access requests increases and the server cannot handle the requests, you can deploy application software on one server, database software on another, and store files on a third one. The architecture layering facilitates future distributed scaling. As the number of service access requests increase, one application will fail to handle the requests. You can deploy more application servers and use LVS or F5 load balancers to balance them. Data is still stored on the back-end database server and the files on the file server. This architecture increases the number of concurrent front-end user requests, but multiplies the pressure on the back-end database server. The previous picture shows that the application servers can support services, but the back-end database server is under immense pressure. To solve this problem, you can cache hot data to distributed cache servers. Before an application reads data from the back-end database server, the application first queries the local cache and then the distributed cache server. If could not find, then keep searching in the database server. It will return the queried data to the application server and at the same time cache the data to the local cache and the distributed cache server. In some scenarios, even distributed cache servers cannot ease the pressure on the database. So the technique is read and write separation, database sharding, table sharding, and partitioning are required to balance requests and release the database pressure. While the newest distributed database can also be used to implement horizontal online service scaling in the same way as application servers do. This architecture can basically resolve user access problems within a region. But for the global users' access, this architecture performs wrong network latency and the user experience is not so good. So, other technologies are required to solve this problem. In most cases, only through the technological measures cannot handle the large amount of concurrent access requests. Service classification and regional division are also required, and content delivery network, the short name is CDN servers, need to be provided for each carrier and region. And coordinate application servers at the logic layer by the message queues. For example, let's divide China into regions like South China, Central China, and North China. And the CDN servers are deployed in each region or province. Then users of China Unicom Guangdong can directly access the Guangdong China Unicom its own CDN servers, rather than through China Mobile or China Telecom, other companies' networks. Till now, we've talked briefly about what is the open source Internet architecture. Let's take a look at what software is required at each stage. Nginx and Vanish are used on reverse proxy servers to separate dynamic and static pages. Static pages are cached on the reverse proxy servers. You can also add a load balancer before the reverse proxy to implement load balancing for static pages. The dynamic pages are processed by application servers after load balancing. At the same time, the message queues are used at the logic layer to coordinate Apache application servers before user access to the distributed cache servers, Redis, and Memcached. MySQL and MariaDB are used as back-end databases. The website images and unstructured data are stored on Ceph, GlastFS, and TFS. This picture illustrated a typical Internet architecture. End users first read data from CDN servers, then access server load balancer under the protection of the cloud shield, and then access Nginx reverse proxy servers. The data is transmitted to Tomcat application servers Internet SLB, then to Redis cache servers, MySQL database servers, and the object storage. So, what are the key factors when we choosing Internet architecture? First consideration is performance. For example, CDN reverse proxy, application service, cache, database, static and dynamic page separation, and image and text separation. Second is availability. Server cluster, cache server cluster, service cluster, database division, table division, and primary-secondary separation. Third consideration is scalability. Flexible scaling based on performance and workloads. Fourth is flexibility. Quick response to environment changes, event-driven architecture, and distributed service. Also need to consider the security, protecting against malicious website access and attacks and against the stealing of important data. Now let's make a summary about this chapter. This chapter explains traditional three-quarters layer service architecture, and the difference between traditional architecture and Internet architecture, and the key factors in choosing Internet architecture. That's all for this section. Thanks for your attending.